Hello, my crypto friends. Today we are gonna talk about how to build an ICO contract with OpenZeppelin. So my first video that I made in August 2017 was also covered that, but since that time the space has changed a lot. There were a bunch of new updates from Zeppelin team. Thank you guys very much. There is a new token standards besides ERC20. There is a ERC827, ERC777. So let's see what has changed and how do you build the same ICO contract like I did in August 2017, but today with a new Truffle, new Zeppelin contracts, and new shiny Ethereum way. So let's do it. So I'm gonna go to OpenZeppelin. So as you probably noticed, the Zeppelin team changed their repo. Now it's called OpenZeppelin -Solidity. So let's get started. So here we have our empty directory, and we need Truffle. So I have the latest Truffle version 4.1.11, and I'm gonna initialize the empty project. If you don't have Truffle, just do npm install Truffle-G, means to install it globally, and then run Truffle init. So once you have that, Truffle after generates a few files and folders for you. So I'm gonna open up the Visual Studio Code editor, and here we are going to initialize our repo as a Node.js repo. I mean, as a Node.js project. So, and we need to install OpenZeppelin dependency, as it mentioned here. npm install Zeppelin Solidity. Save. Okay, so I increase the font so you can see it more clearly. So, okay, we installed this dependency. What do we do now? Just to make sure everything is working here right now, I'm also going to install npm install Ganesh CLI, but I already have it installed as a global dependency, so I'm just gonna run Ganesh CLI. So Ganesh CLI is basically test RPC, but it's a fake Ethereum node for local development. So now we have it running on localhost 8545. And just to make sure everything is still working, we haven't written anything. We just want to make sure we have the test RPC working and we can deploy contracts. So I'm gonna say, so first of all, we need to provide our config file for Truffle.js. So we need to say networks, and we need to say development, our development network. And now I forget how to do it, so I'll probably open up Truffle config from OpenZeppelin. And here we just need to provide the host, port, and network ID. All right, and by the way, one more thing that I want to do, I'm gonna specify the Solidity version. I don't know how to do it, so I'm just like Truffle Solidity SolC configuration. So the reason why I'm typing this, so you can also see that I just, it's not about that who knows how to do stuff. I get this information online. It's not some kind of magic or something. So here we're simply looking for SolC config, and here we go. I just want to make sure we're using this optimization enabled that I want to add here. So now, just to make sure everything is working, we have one contract, which is migration.sol, which is the default contract that generates by Truffle framework, and I want to do Truffle compile. And Yep, so if it's successfully compiled, you should see this generated migration.json file, which means it was compiled successfully and there is some information like ABI, which is application binary interface in Ethereum world, the bytecode, and we can also see which Solidity version it was used, the compiler. It was using 0424. That stuff we need later on for Etherscan contract verification. So now I want to make sure that we can run our migration script, which is here. So Truffle migrate -- reset. And we should see that it's, yep, so it's working. That means we have a connection to our fake RPC node. And now we're gonna write our token contract. So we're gonna create, let's say, let's choose the name, saying like weather token. It's a token for our weather. That's so weird, right? Okay, so first of all, we need to specify our version of Solidity, since we have 24. And we're gonna define the name of the contract, weather token. And that's about it. Let's see if it compiles. Okay. All right, so we have successfully compiled it. Now let's see how we can use OpenZeppelin Solidity repo. So I have no idea what's going on there. I'm just going into contracts and I'm like, what do we need? We need a token contract. So which standard we want? ERC20, 721, 827. We're just gonna use the old simple ERC20. So there are quite a few things. You can read through all of this, but basically those are like, it's like a shopping cart. So you want the ERC20 token and you want some additional features in it. Do you want to be able to pause the token? You can add extension pausable token. Do you want to be mintable? You can add a mintable token. Do you want some kind of token time lock or something? I have no idea what it is, but I assume it gives you some additional, it gives you some additional method release. So for our purposes, we're just gonna use mintable token. That's all we need. So how I'm gonna do it? I'm gonna open node modules. We have this dependency, contracts, token, ERC20, mintable token. And I'm gonna say import OpenZeppelin, contracts, token, ERC20, mintable token, that's all. All right, so now I want to say weather token is mintable token. And let's make sure it still compiles. So now we can see that it's reading from OpenZeppelin dependency. And we have successfully compiled it. So what else do I need? So in my tokens, I like to specify name, symbol, and decimals via constructor. And there is a contract for that called detailed ERC20, which is just an extension, nice extension that gives us this constructor. So let's do that. I want to import this contract and I want to use it. All right, so now we need to define a constructor. So since we're using the new version of Solidity, not like previous version, you would define it this way, like a function with the same name as a contract that would behave as a constructor. Now with the newer version, we don't have to do that anymore. We can just say constructor, and here we need to call this constructor with the some parameters pasted in. So with the detailed ERC20, let's look at the constructor. It has three, let me zoom out a little bit. So it has these three constructors. So we just need to paste them in from our constructor to the detailed ERC constructor. That's it. Let's compile it. And it's working. Nice. So let's deploy it. Let's deploy it to our fake RPC node. So I'm going to create a new file called deploy ICO.js. And we want to say weather token. And since we have some parameters, I also want to use asynchronous JavaScript. So I'm going to do that. And I'm going to place await. So we have three parameters, right? Which is name, symbol, decimals. So the name would be weather token. The symbol would be WRT, sorry. So that's it. Let's see if we can deploy this contract. Here we go. So we just proved that we have built a deployable contract that is up and running. And now, let's build the ICO contract. So we have the token, mintable token. We can add some more features to it. I don't know, like pausable token if we want. You probably already figured out how to do it. You just import this token there and just add a inheritance to your main contract, and that's pretty much it. You can make it also as a burnable token. Usually that's a good way of doing it. So let's do that. Actually, let's not do that. We can do it later. ERC27, I like this token a lot. It provides some cool features like transfer and call with additional bytes data. Maybe we can do that in the next tutorial. So here, we need a Crowdsale. We need to make some Crowdsale, like very simple one. So let's do that. So we have to create a new contract called weather Crowdsale. That's all. I'm gonna copy some of this stuff here. Just copy paste everything we had in a weather token. So on here, we need a Crowdsale, just basic Crowdsale Solidity. And we don't need that. And then we need to call it Crowdsale. And it should inherit from Crowdsale. And let's look at the constructor. So the constructor should look like so we need to provide a rate ERC20. So let's see. All right. So and then we need to call this constructor with the rate, wallet, and token. And by the way, this is the type of ERC20 contract, so we need to import this contract as well, so we can successfully compile that. That should be it. Let's see if we can still compile it. All right, that looks good, but it's just a simple crowd sale with no cap, no time limits. So it's very boring contract. We probably want to add something to it. For example, in a validation folder, we can see there is a timed crowd sale, so we can bound our crowd sale with time, opening time, closing time. So I probably should add that feature. So let's do that. Validation, time crowd sale, Solidity. And I need to add this here. So let's look at this contract. How to use it? I have no idea how to use it, honestly, guys. Don't think that I study this everything. I just look at it. Solidity is not that complicated. So in this contract, we have two parameters that we need to paste into our time contract. So since it's already a long list of parameters, I usually like to do it like this so we can read it better. Okay. Okay, so now we need to call TimedCrowdsale with those two params. Oops. And let's make sure we can still compile this contract. Okay, so we added some bounds on time. Let's add also as well a cap to our crowd sales. So let's do that. So we just only need to add one more param. So I'm just gonna import this contract, CappedCrowdale, and I'm gonna add it to my inheritance list, and I'm gonna call it with a cap, and we need to add a cap here. Let's make sure we can still compile it. All right. Awesome. So now let's write a deployment script for this contract. All right, so we have the token here. So we'll probably need the token address from here. So deploy token would equal to is now read. Okay, yeah. So await weather token contract that deployed. So let's make sure it's doing its thing. All right, and we can do Truffle migrate. Yep, that's the one, that's the one. Okay, correct. So now let's deploy the ICO contract. Let's write a script for ICO deployment, Crowdsale. Okay, now deploy Crowdsale, and we have quite a few parameters. So let's look at them. We need those params. So I'm just gonna copy them, put it here, comment it out. Okay, so we need to provide rate. So let's define a variable rate equals 1000, which means for every 1 ether that would be sent to this contract, it will issue 1000, what's it called, WRT tokens. So next, we're going to define some wallet. So wallet is where the funds should be collected. So you can use some kind of multi-signature wallet, usually is used, or just, I'm going to use the same account that is going to be used for deployment. I'm just going to use that. So usually it's a third variable. in Truffle. So I'm gonna say, okay, whoever is deploying this is running the script, make an assignment to that wallet. Token contract. So we already have that, deploy token.address. Opening time. So we can define time now would be math for day.now divided by 1000. And yeah, maybe. I also like this little utility from Zeppelin team in their test folder. Like if you want to learn how to do Solidity, you just go to Zeppelin and read everything that they have there. They are awesome guys. And there is like these helpers, and there is this, let's see, increase time. Yes, I like this function called duration. Very helpful. So we can paste it here, but don't make an export. Okay, so if we want to say now, time from now, and plus duration, let's say seconds plus 30 seconds. I like to do that because I remember, like in a Crowdsale contract, there is this conditional check that when you deploy a contract, the opening time in a timed Crowdsale has to be more than now. And sometimes you just want to give a little bit of time. But for example, or you can say, I want to deploy this contract, so the ICO should start, let's say, in 2 weeks from now. So we can say, okay, days, like 14 days, and 14, something like that. But for now, for these purposes, we're just gonna say time now starts here, and the closing time. So the closing time would be, let's take time now, and let's call it opening time. Opening time, and this is actually time now. Because time now. Let's make it more pretty. Time now, and this would be like, let's close the ICO in a year, like plus year, like 1 year. Okay. Opening time, closing time, cap. All right, so the cap is like, what's the maximum that this Crowdsale will allow to collect in Ethereum? So usually it's in way. So I think the Truffle has this variable, global variable Web3, and I think you can do two-way. So because I do not remember at this particular moment, I think I'm just gonna comment this out and I say two-way. Let's say our cap would be like 100 Ether. So I just want to console log and see if I remember the syntax correctly, because I'm not sure. I think that's the way you do it. Yep, I was correct. So this is how much in way 100 Ether. So we can say const cap. It's 100 Ether. Okay, now we have our variables. So now let's do it. So we want to deploy this contract with the following arguments: rate, wallet, token address. I need this variable. Token address, opening time, closing time. Oops. And cap. Let's see if it deploys. Hopefully it does. Great. So now we have deployed this contract to fake Ethereum node. How about we deploy to real network? Like, I mean, you can deploy to a real network or to some testnet network. So I used Etherscan in my previous tutorial, so I want you guys to use the same Etherscan. So that means we're going to use colon. And I want to reuse the same script for colon network. So let's do that. Here we're gonna say we need to define an address from which it's going to be deployed, and we need to have some funds into this account which is going to deploy this contract. So I really like this library called Truffle HD Wallet Provider. What it does is basically you can create your wallet from the seed phrase. Don't enter your real seed phrase, come up with something temporary. It will be your temporary account. I can show you how to use it right now. So we need to install this dependency first, and I'll show you how to use it. So basically, you come up with some seed phrase. This seed phrase will generate your an Ethereum address with its private key, and the same seed phrase will always generate the same account. So don't share your seed phrase with anyone. Don't put a lot of money into this seed phrase. Just put a little bit so you can test your deployment script. Don't try to deploy it on a mainnet first. Try use test nets like POA Soko or Kovan or something else like Robson or Ringbee. And then after you have tested everything, then you can try mainnet. In my personal experience, Truffle migrations do not work well with mainnet for some reason. Sometimes it's just times out because it cannot wait for blocks or transactions. And you also need to specify, yes, another thing, that the gas price, which gas price you're going to use for when you deploy something to the network is as a variable here in your Truffle configs. So, okay. Let me show you how to use this library. I'm just going to quickly show you what it is. So let's say variable HD wallet equals this dependency require. And now we have this. So let's say our instance equals new. I don't remember how to use it. So let's look at that. New HD wallet, so we have two arguments, mnemonic phrase and RPC endpoint. So let's say our mnemonic phrase would be POA is awesome. And we have empty RPC endpoint, so the instance will always generate this address. So now I can use this address to get some funds for like fake Ether for colon network. And I will show you how to do that. So basically you need to go to, there is a Gitter channel. It's a free faucet. Oops, my computer is slow a bit. So there is a Gitter channel colon faucet. And here you can request free Ether. Since I already have them, I'll just make a transaction from my account.